Okay, we have to know how to write the products of acid-base reactions. So when an acid mixes with a base, it's neutralized. And you might remember this from chemistry last year, when you put some, hydrochloric acid in a test tube and you dropped some indicator in, it went red, and then you mixed it with a base. The base was probably blue when it had the indicator in it, and you mix them together and it goes green because it's neutralized, right? And the reason why we do acid-base reactions is because they're so common. You might want to neutralize, you might want to know how to neutralize these if you get stung by a bee, or have indigestion, or want to clean up some kind of spill that requires neutralizing, or maybe you just want to make bath bombs, whatever. Acid-base reactions are the sorts of things that you're dealing with every day. So predicting the products is actually not that difficult for these. I'll write out an equation for you. So we got hydrochloric acid, and you might remember the acids mostly have hydrogens in. The common acids that we use have a hydrogen, and as our cation, it's not working. Hydrogen is our cation, and some kind of non-metal is our anion. And you put it with a base, which is usually a hydroxide, and I think hydroxides is all we're going to use this time. And a base is made up, again, of a positive. It's a positive cation and a negative anion. In this case, you've got sodium as your plus and hydroxide as your minus. So when they neutralize each other, what happens is they just kind of swap. So the hydrogen, which is the plus, goes with this minus, and this plus goes with this minus, and you rewrite it. So on the other side, you get NaCl as your salt, and you get H and an OH that looks like this. So anytime an acid and a base neutralize each other, you get a salt and water. So, and you just swap, the anions and the cations just swap over, kind of partner swapping. Here we go. Here's another one, nitric acid, which has got a H and a nitrate. And we're going to put it with potassium hydroxide, which is a K, potassium and hydroxide. And we're going to do the same thing. We're just going to swap them over. I might use some colors to help you out. So this anion is going to go with this cation over here to make a salt. And the hydrogen and the OH are going to make water. So KNO3, and of course you've got to go to your charges and know that K is +1 and NO3 is -1. So that's KNO3 plus H2O. So the idea is easy enough. The hard bit is when you've got to write a more complicated salt or balance an equation. So I'll find one of those. Oh, yep, got one. Yeah, let's do that. We've got H2SO4 as our acid, that's sulfuric acid, with lithium hydroxide, which is our base. Acids have hydrogens pretty much always, and bases have hydroxides pretty much always. So the H and the OH are going to go together to give you water. And let's pick another color. Oh, I didn't change color. And this, the sulfate and the lithium are going to go together to give you a salt. Sulfate is SO4 2-. I might write that over here. SO4 2. That's not a minus, 2-. And lithium is Li+. So you can see you're going to need 2 lithiums. So it's going to be Li2 SO4. Is it balanced? You've got an SO4. Oh, there's only 1 lithium here. You've got 2 lithiums over here. So we're going to need to put a 2 in there. two LiOHs. So we've got two O's, 1, 2, 3, 4 H's. We're going to need a 2 here. And if you want to make sure it's balanced, write it all down underneath. I'm just going to count. I've got 1, 2, 3, 4 H's on that side. 1, 2, 3, 4 on that side. We've got an SO4 there. We've got an SO4 over here. We've got 2 lithiums over here. We've got 2 lithiums over here. And 2 O's over here and 2 O's over here. So that's balanced. So that's why you needed to learn to write the salts and to balance the equations. And all the other common reactions that we're going to do are just as straightforward as that. So have fun.